video, we're going to talk a little bit about the basics of ignition coils. Now, real quick, an ignition coil. Like the simple coil I've drawn here, essentially what an ignition coil is simply two coils of wire in one housing. Now, we have different packaging for them. We have an old school coil. We've got an HEI coil. We've got what we termed an E-coil. Then, of course, there's DIS and COP coils. Not that kind of COP. Coil on plug, COP. More of our acronyms. By the way, you will find a term sheet on D2L. It doesn't matter which kind of coil we have, they all do the same job. The two coils of wire in them. All right, so we have something like this. Okay, so our basic circuit, what we've got going on. We have our two coils of wire inside our ignition coil. We've got our primary windings and our secondary windings. You'll notice I've got way more secondary windings than primary windings. This ratio determines coil output. We're going to give constant 12-volt supply to our primary windings. We're going to put a switch, that switch, on the ground side. Now, we are going to put a little tie back together to the secondary because, as you should remember from electrical, anytime we have a circuit, it has to complete. So we got to give the electrons that we're going to send over here a way to get home again. So we're going to make sure that they're tied in to our 12 volts somehow. There's a couple different ways to do this. But as we energize this, even if this is tied together here on positive, it takes way too much power to jump that, so nothing's going to really happen over here. There isn't really a ground. This is our spark plug down here. So what's going to happen? We energize the primary when we close this circuit. So hopefully you remember that when we send power through a coil of wire, we create a magnetic field. So we're going to start creating that magnetic field. And those magnetic lines are going to cut across the secondary. And as long as this switch is closed and we have power here, we're going to be building that magnetic field. Now, the minute we open that switch, this field collapses. As it collapses, it's going to cut back across the secondary windings, and when it does, it's going to induce voltage in those windings. Since there's a whole lot more turns here than there was here, it's actually going to induce a higher voltage in those windings at a very much lower amperage. And that high induced voltage, up to 50,000 volts, now wants to find a way to ground and back around. And the most convenient place for it, if the system is working right, is right there at the spark plug. It's going to come down, ionized plug gap. The rest of our electrons, once the ionized plug gap, are going to continue their march back up to the system, and we're going to start all over again. We're going to close the switch, build a magnetic field, get it all ready to go, open the switch, collapse the field, induce a high voltage, jump the gap, and back around again. That is our basic coil operation. So, in our complete circuit,
All right, so we have power, trigger, switching, transistor inside some form of ignition module, secondary, including ignition coil, spark plug wire in this case, spark plug, pretend that's a spark plug, and finally spark. Put it all together. Powers the ignition module and the positive side of the coil. Our trigger sends a signal to the ignition module. Ignition module uses the engine speed and position information to operate the switch or transistor that's inside here. That transistor is working on the negative side of the ignition coil. When we close that transistor, we create a circuit across it. It starts to build that magnetic field. We always have power. We always have power to the positive side of an ignition coil. When we take that ground and that switch closes in there, we provide ground to this, we build that magnetic field. It grows larger and larger. When we turn that switch off, now that magnetic field collapses down. As it does, it collapses across the many more turns in the secondary windings. As that voltage is induced, it needs to go somewhere. It's going to head out the spark plug wire through the spark plug, jump across the plug gap, and make a spark. Now, hopefully at the same time all that's happened, our piston has come up, compressed some gas, some air, some atmosphere inside there. We've injected a little fuel in it so that that spark has a job to do, has some work to do. Again, power, trigger, switching, secondary, plugs. If we have all of that, it works right at the right time, still something we're going to talk about, we get a spark. So coils, doesn't matter what they look like, it doesn't matter their packaging, they all do the same job. Some are more efficient than others, some are higher output than others. At the end of the day, it's a step-up transformer, it's a couple of coils of wire, it works off induction, and it makes a nice fat spark, which will either hurt us or gives our ignition a nice boost. With that, we'll catch you in the next video.